Welcome to Real GMAT Problems, episode 17. Doing real GMAT problems really helps you recognize key concepts on test day, so let's talk through a few examples together. The problems that we're going through today are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. I know many of you won't be in that situation, and that's no problem. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap with the questions we'll work through here. The official guide contains retired GMAT problems that have appeared on past exams, so it's a really useful way to get prepared. I'll give you a chance to work through the solution on your own if you want to, and then I'll discuss my thoughts on the problem and my recommendations for what to take away. What I recommend doing is pausing after I read through each problem and, at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but see how far you can get. It's a great workout for your brain, and it's amazing how well visualizing helps improve what you write down when you eventually return to the scratch pad. If you're in a situation where you can physically write down what you would on test day, like on a plane or a train, that's ideal. Here we go. This is problem number 56. Which of the following is not equal to the square of an integer? Just going to read that again. Which of the following is not equal to the square of an integer? Option A is the square root of the square root of 1. Option B is the square root of 4. Option C is 18 divided by 2. Option D is 41 minus 25. And option E is 36. Again, I recommend pausing if you want a moment to work through that. This is a great problem to test your math basics, including definitions, and also an interesting twist with 12% of people picking option A, which is unfortunately not correct. So we'll explore that a little bit more in a moment. It's also a good example of how the exam likes to phrase things in potentially confusing ways, which is a good opportunity for us to practice being cool under pressure and also taking our time understanding exactly what the problems are asking us to do. At the end of the day, this one is just about some fairly straightforward computation and making sure you read well and understand basic definitions. So let's walk through all that. First, what might a correct solution look like? Most of us are probably going to want to just look at the answers and do some computation to test which is not equal to the square of an integer. This is an interesting problem in that we're basically forced to use the answer choices rather than a typical, what I would call, quote unquote, top-down math problem, where we're just given some constraints and then we can just solve our way to the bottom of the page and the answer. It's not something that I've seen throw a ton of people off, but it's definitely worth mentioning so that it's not a surprise when you see this kind of thing on test day. It's actually fairly common on the quant section. The other piece that I can see people getting confused about is the word not. Now, on the exam, they've actually capitalized the not. They've put it in all caps, but you might be surprised how many people still miss that or just forget it as they get into the math part of the problem. So it's something that I've seen a lot of people make as a mistake. Most of us just are used to more straightforward questions on math tests. Things like which of the following is equal to the square of an integer. That would be more common in a school math test. So it's okay if it takes a bit of adjustment to get super comfortable with that kind of thing. That's actually partly why we're here right now. The more you can get exposed to this kind of thing before test day, the more natural test day should feel. Let's start by breaking down the question. What's the square of an integer? If you're not sure, please check out our Math Basics episode on exponents, which is going to be linked in the description below. Also, if you're not sure what an integer is, if you're just starting out on your GMAT journey, or maybe you've been on this journey for a while and you still haven't taken the time to figure out what the definition of an integer is, it's probably a good idea to check out the basic definitions episode that's linked in the description below as well. In fact, you might like that whole Math Basics series if you're just getting started, just to make sure that you're reskilling and in a good place to tackle these slightly more complex questions that assume that you know the basics well. Otherwise, you're probably aware that the square of an integer is any integer multiplied by itself. For example, 4 is the square of 2. Similarly, 25 is the square of 5, 49 is the square of 7, and so on. So we're looking for an answer choice that does not produce a number like that. Most people are going to find starting with option A and moving down the list of options pretty natural, and there's no problem with that. So let's just go ahead and do that. Option A is the square root of the square root of 1. Well, let's start with the square root of 1, and then we'll take the square root of that number. So the square root of 1 is asking you what number can you square to create 1 as a result. And we've got a whole math basics series on roots as well if you want help with that. So hopefully you're thinking 1 times 1 is 1, which is true. So the square root of 1 is just 1. If we perform that operation again, we still get 1. So hopefully that's not a surprise. So square root of 1 is 1. Square root of 1 is also 1. So if we computed A, the result would just be 1 by itself, and 1 is the square of an integer. 1 times 1 is 1. We just talked about that. So that's not what we're looking for here. We're looking for an answer that is not the square of an integer. So now you can start to see why, even though that not is capitalized, it can get a little dicey, especially when you add some time pressure into the situation and some high stakes. So we'll come back in a moment to why I think so many, again, 12% of people are picking that answer, even though it's wrong. But let's work through B first. So what's the square root of 4? Hopefully you're thinking square root of 4 is 2. And 2, is that the square of an integer? Think about that. Is there a number out there that I can multiply by itself that's an integer and get 2 as a result? I can't. There's no integer I can multiply by itself to generate 2. 2 does have a square root. It's just not an integer square root. And the question's asking us for the square of an integer specifically. And so option B is actually going to be our correct answer. B as in beta. Square root of 4 does not produce the square of an integer. If you step back for a moment, I do think that that is kind of tricky if you think about it, because 4 is the square of an integer. So it requires a bit of deeper thinking and reasoning in the moment in order to produce the correct response. And when you add the high stakes, the time pressure, the potentially uncomfortable environment of test day, all those things can cloud our minds a little bit. And all of a sudden, we just like the familiarity of seeing 4, and 4 is the square of an integer. And it just takes that little bit of extra energy to think through that. Now, hopefully, most of you didn't struggle with that. That's awesome. But some of you may have, or you may struggle quite a bit with that kind of thing. And I've got some tips for you on that in just a sec. First, though, a lot of GMAT quant questions are like this. Recall the section is called quantitative reasoning, not quote unquote math knowledge. If the test was called math knowledge, we'd be doing different types of problems, in my opinion. So while it's extremely important and useful to have math knowledge to make reasoning through these quantitative questions easier, or maybe even possible in some situations, we'll still usually have to go a little bit beyond math knowledge to get questions right consistently in the quant section. And I just want to put that on your radar so that it's not a surprise when you see it, like I said earlier. Now, on the exam, I would stop at B as long as I'm 100% confident in my math. And if I've done a good job building up my math basics, and I go through a decent process here, and I follow some simple guidelines to make sure I'm not missing questions I know how to do, such as writing what's given and what's asked 100% of the time. We'll circle back on that a little bit later today. Then I'm just going to pick B, and I'm just going to go with it. If I'm not feeling super confident, though, which can happen in certain types of problems, then I might test C, D, and E just to get that extra level of certainty. And that's totally fine if that feels better to you and you're not having time trouble in this section. So here's how testing those would go. C is 18 divided by 2, which is 9. And 9 is the square of 3. 3 squared is 9. So C does produce the square of an integer. That's not what we want here. We want an answer that does not produce the square of an integer. D is 41 minus 25. That's 16, which is the square of 4. 4 squared is 16. And E is 36, which is the square of 6. 6 squared is 36. That's the least chosen wrong answer. So looks like people are looking at 36 and for the most part, pretty much figuring out what the deal is there. So B is the only option that doesn't yield the square of an integer. It's kind of interesting to note, let's make a few notes here actually. It's kind of interesting to note first that this is a very definitions focused problem. So in some regards, it's very much about math knowledge. But I think my points about reasoning above still stand. I don't know if this is like a quote unquote pure math question. I think it'd be kind of a difficult argument to make. So why are so many people picking A? Obviously, most of us on the business school track are at least competent with reasoning through things. So, so what's the story with this? I always tell all of you, and forgive me if I'm just using this analogy way too much, but imagine 100 of the brightest minds in business of your age and generation in a room, and 12 of them go for A on this question. Like it's kind of like, man, how's that happening? You know, these are really smart, motivated people. What's the deal? I think there could be a few reasons why so many people are picking A. First one is probably that people have memorized that when you take the square roots of numbers, there's a positive and a negative solution most of the time. And this is like a very well-intentioned thing to memorize when you're studying for the GMAT. And that actually is true when you're taking the square root of variables. But it's probably worth memorizing that it is not true when you're taking the square root of only numbers on the GMAT. There may be exceptions outside the GMAT, but we're talking specifically about how the GMAT thinks about these things. So that's really worth memorizing. If you're taking the square root of a known number on the GMAT and not the square root of a variable, like it's not an equation, it's just square root of 9 by itself, that's always going to be positive. Square root of 9 by itself is always positive 3 on the GMAT. The time where you want to think of a positive and a negative solution is when you're also square rooting a variable at the same time, such as an equation like x squared equals 9. If it's x squared equals 9 and you're going to take the square root of both sides to isolate x, that has two solutions. X could be positive 3 or negative 3. So let me just repeat that. If you're just square rooting a number by itself and not square rooting a variable, it's always positive. If you're square rooting a variable and a number at the same time, like in an equation, then you're going to want to at least consider whether there could be a positive and a negative solution. If it's x squared equals 0, you're not going to get a positive and a negative solution. But 95% of the time or better, sorry, or more on the exam, you're probably going to have a positive and a negative. The exam really likes to test that kind of thing. But every once in a while, they'll do something like what they do in A, where it's kind of like they knew you studied that, and then they're kind of like stabbing you in the side. You know, it's kind of like a gotcha moment or something like that. At least that's kind of how I think about it. I don't know if it's really that devious or that intentional, but it feels that way. It feels very personal when I pick wrong answers like A on GMAT questions. I'm just speaking for myself. Maybe I'm alone on that. Again, it's probably not personal. I'm just saying it feels that way. So if you're not sure why that works, like why when you square root both sides of an equation, you should be looking at a positive and a negative solution, please check out the exponents lesson that's linked in the description below. I'm not going to go long on that here. Already went long on that on the Math Basics episode. So let's wrap this up. Please do yourself a favor. Just memorize that when you're taking the square root of a number on the GMAT, it's positive. When you're taking the square root of a variable, it could be positive or negative. Many questions hinge on that fact. Now, why might that lead someone to pick option A? Well, if you look at A and think, oh, that could be positive 1 or it could be negative 1, like you think about what I just said wrongly, then you would think negative 1 is not the square of an integer. And that is true. Negative 1 is not the square of an integer. So at that point, you might think the answer is A, stop, pick A, and not even think to check B. So hopefully you're ahead of the curve on that specific thing as a result of being here right now. Or maybe you didn't make that mistake at all, in which case, hopefully we've just reinforced some good habits. There are definitely other reasons people might be picking A. For example, I think probably the most common, if I had to guess, is that people just miss the word not in the question or they forget about it. And they just pick the first answer that does yield the square of an integer. So they're like, oh, square root of 1, that's just 1. That's the square of an integer. Great. Huh. Joke's on you, GMAT. And then they just move on because they're feeling the time pressure. So that's why I'm going long on some of these questions. These are low difficulty level questions. A lot of you, if you're coming in at a high level in quant, or you've always been great at standardized tests and you're just kind of getting your feet wet, checking out the whole GMAT thing. I don't want you to think that all the questions in GMAT quant are at this level, because this is actually a relatively low difficulty level GMAT question. You're definitely going to see questions that are way, way, way more complicated and difficult and challenging. And I mean, all the difficult words we could come up with. The GMAT quant section is very well orchestrated to be hard for the vast majority of people. Not saying it's hard for everybody. But I want to start at a low level for a few different reasons. Number one, it's a good segue from the Math Basics series for those of you who are not starting at a super high level in quant. And number two, I think you're going to find that as we get into harder and harder quant questions, a lot of the just comically basic things that we might be discussing here are going to scale super, super well on those hard questions. Like, hopefully, I'm going to help you realize, like, wow, this hard question is really just like a bunch of these smaller, easier, basic things put together. It's not true 100% of the time. But I think when you can see that maybe 50% or 80% of hard quant questions are what I just talked about, I think it can just take some of the mystery and some of the like psychological challenge out of the quant section. And I think that's good for a lot of people, everybody. I think the psychological weight of this exam is already so big. And I don't even know if that's good or bad. Like it just kind of is what it is. But I think if we can take away any of the stress that does not enhance your performance, then you're probably getting into B school faster, you're probably living the dream faster, and you're probably serving the world at a higher level, which really is the ultimate goal here. So weirdly, there are a lot of ways to miss this question, even if you do know your basic definitions well. And that's why you've heard me recommend to write what's given and asked on every problem so much. And I'm probably just going to sound like a broken record this whole series and through the end of this episode as well. But if that's all it takes is me repeating myself a bunch to help you finish this process faster and avoid all the pain and pitfalls that I went through personally in this process when I was in your shoes, then I'm willing to do it. So if you have questions on any of this stuff, feel free to reach us at the GMAT strategy on current social channels. You can DM us if you like to DM. If you prefer email, you can email us at contact@thegmatstrategy.com, contact@thegmatstrategy.com. And we'll do our best to help you out. That's probably everything that's worth discussing on that problem. Let's try another one. This is problem 57. The problem says Fermat primes are prime numbers that can be written in the form 2 to the k power, and it's 2 to the k power, like imagine that in parentheses, plus 1 outside the parentheses. So the plus 1's not in the exponent. It's 2 to the k plus 1, where k is an integer and a power of 2. I'll read that again in a second. Which of the following is not a Fermat prime? I'll read that again. So Fermat, I believe, is the name of a famous mathematician, and they're kind of, I don't know if they're coining this term or if this is a real term. Actually, I probably should look that up. But they're just saying Fermat primes. They're basically defining for the purposes of this problem a certain type of prime number. So they say Fermat primes are prime numbers that can be written in the form 2 to the k power, open parentheses, 2 to the k power, close parentheses, plus 1, where k is an integer and a power of 2. Which of the following is not a Fermat prime? Option A is 3. Option B is 5. Option C is 17. Option D is 31. And option E is 257. Again, I recommend pausing if you want to visualize your solution path here. Highly recommended. This is interesting because it's like a slightly more complex or maybe very, very complex version of the previous problem, but it's a great example of how often this way of asking questions comes up. So just trying to help you get more comfortable with it, like I was saying before, so it doesn't cause you to miss things that you deserve to get credit for. There are a few additional concepts involved in this question, so I recommend you check out our special cases math basics episode, which is linked in the description if you're not sure what prime numbers are, or if you're just getting started and maybe you're feeling a little fuzzy about what prime numbers are, like maybe it's been a decade or two since you thought about what a prime number is. That's totally, totally fine if you're in that situation. Like the previous question, assuming you know your basic definitions and are comfortable with exponent rules, you should be able to get this kind of question right consistently. I do think there's some confusion in how the question is asked, but if you don't make a reading, writing, or math mistake, you're probably nailing this one, which is good news. So let's talk about a potentially correct solution path. Let's talk about a potential solution path that would be correct. Once again, we're going to be forced to use the answer choices here. In this case, though, the math and logic are a little bit more complicated, like I said, so we're going to use a slightly different approach. We're given this equation to create what they call Fermat primes. That's again 2 to the k plus 1. But there are some interesting restrictions on k. It has to be an integer, and it has to be what's called a power of 2. So let's break that power of 2 part down a little bit. If you're solid on your definitions, you probably instantly knew what that meant. But if you didn't, power of 2 just means it's the result of taking the number 2 to any integer exponent. This is very related to the concept of a square of an integer that we were looking at in the previous problem. The square of an integer is a type of power. It's to the power of 2. But if we take a number to the third, fifth, or seventh power, that's another way of saying we're taking it to an exponent. That's all that means. So 5 to the 2 can be said as 5 squared. It can be said as 5 to the exponent of 2. It could be said as 5 to the power of 2, or it could be said as 5 to the second power. All of those phrases mean exactly the same thing. It means take 5 and multiply it by itself. Okay, so again, this is why we made that exponents lesson for you. I'm going to go deeper and longer on that there if you want to firm up your understanding of exponents, as it were. So what are some quote unquote powers of 2? Well, this is a little different because a power of 2 now means we're talking about the base. 2 is the base that we're taking to any integer power. So it's almost like a flip of some of the definitions we were talking about, and I think a lot of people are probably getting turned around by that here. So 2 to the first power is 2. 2 to the second power is 4. So 4 is what's called the second power of 2. 2 to the third is 8. So 8 is the third power of 2. 2 to the fourth is 16. So 16th is the fourth power of 2. So 4, 8, 16, those are all powers of 2. That's what this question is telling us k has to be. It has to be a power of 2, meaning it has to be 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, that kind of thing. Again, totally okay if you were a little fuzzy on those basics. It's probably been a long time since you thought about these kinds of things, and that's totally normal, and also why we're here discussing this stuff in advance of test day. As you can see, though, they are tested on the GMAT, so it's worth brushing up a bit, and that's why we made that whole math basics series for you. So please take advantage of that if you think that would be helpful. Now that we know what powers of 2 are, we know our possible values of k. K can be 2, k could be 4, k could be 8, k could be 16, on and on. So let's apply that information to the answer choices. If we take 2 to the k plus 1 and we start with k equals the first power of 2, or 2 to the first power, which is just 2, we would get the Fermat prime is 2 to the second power, which is 4, and then plus 1 outside the parentheses. So the result there would be 5. And so that allows us to rule out option B, as in beta, because that's 5. And we're looking for something that cannot be a Fermat prime. That's what the question asked us. It said, which of the following is not a Fermat prime? Well, I just plugged into the formula and I got 5. So 5 clearly can be a Fermat prime. So that's why we take out option B. Personally, I think this is a situation where solving a few iterations of the formula is going to be a little easier than setting the formula equal to 5 and then solving for k. But some of you might be more comfortable with that approach, and that's completely fine. I'll actually demonstrate what that might look like in a little bit. But I'm just going to take what I think is kind of the simpler approach, which is just like kind of plug in some potential values and see what happens. And I think it's a good way to get traction on these questions that might be a little like definitionally weird or unusual. So let's try another power of 2. Let's try the second power of 2, which is 4. That would give us the formula 2 to the fourth plus 1. 2 to the fourth is 16, plus 1 is 17. So that means we can eliminate option C, as in Charlie. 17 can be a Fermat prime. Let's try the third power of 2, which is 8. That would yield 2 to the 8 plus 1. Might take you a little while to figure out what 2 to the 8th is, but if you multiply 2 by itself 8 times, eventually you would get 256. 256 plus 1 is 257, so we can eliminate option E. That leaves us with option A, which is 3, and option D, which is 31. At this point, it would be totally okay if you're a little stuck or you're not sure how to get past this. Like, was it 3? Is it 31? I don't know. There's a few different directions you can go there. I think personally it's probably best at that point to set the formula equal to 3 and then set the formula equal to 31 and see if you can reason through the solution. So let's do that. And this is what I was talking about earlier. Some of you might have done this for all 5 answer choices. Totally cool if that's the most natural thing for you to do on this problem. Let's start with 3. So I'm gonna take the formula for the Fermat prime, 2 to the k plus 1 equals 3. And let's use some basic algebra to simplify. Let's subtract 1 from both sides. And we've got a math basics episode on equations and algebra if you need some brushing up there. Subtracting 1 from both sides, that yields 2 to the k equals 2. Now, the only way for that to happen is if k is equal to 1. The only way for 2 to the k to equal 2 is if k is 1. But I don't think it's very obvious that 1 is a power of 2. But it actually is. 1 is a potential power of 2 because if we take 2 to the 0 power, again, this is explained in depth in the Exponents Math Basics episode, linked in the description. If we take 2 to the 0 power, that equals 1. So 1 is actually a quote-unquote power of 2. It is the 0th power of 2. It's kind of tricky, but it's the kind of thing that the exam likes to test us on. It's kind of like the exam is asking like, oh, you're prepared? Well, how well prepared are you? Have you covered all of the details? I mean, think about making a decent PowerPoint deck versus an exceptional PowerPoint deck. There can be a lot of attention to detail that goes into something like that. Now, I'm not saying business is all about PowerPoint decks, but it's a valuable skill. So it's the kind of thing that I personally think they're testing out there. It's pretty unusual to just like practice something one time and fully master it. So even if you went through that math basics series and you kind of vaguely remember 2 to the 0 could be 1, I wouldn't be afraid to just put some heavy repetition into those episodes because repetition really works when it comes to the learning process. And I would love to be the kind of person who just sees something once and then remembers it forever and instantly understands it. I'm not that person. Just statistically speaking, you're probably not that person. And that's totally cool. Let's just embrace the reality of that, put in some reps, and that should do the trick and form a really good math basics foundation for you. So starting to tie this off, ultimately, that just means A can be a Fermat prime because 2 to the 0 power is 1 and 2 to the 1 plus 1 equals 3. So that's going to make our option D, as in delta, which is 31. 31 cannot be a Fermat prime based on the definition we're given. If you were unsure, you could have done a similar thing to D to test it out. We could have set 2 to the k plus 1 equal to 31, then made the same algebraic move, subtracted 1 from both sides to get 2 to the k equals 30. But then we'd be stuck because there's no exponent we can raise 2 to get 30. No integer exponent, excuse me. There's no integer exponent we can raise 2 to the power of to get 30. So that's another way that you might have been able to discover that D is the correct answer. It cannot be a Fermat prime. Either method works. Just for the record, plug in powers of 2 and test the answers. That's what I did, and that got me down to A and D. Or you can set each answer equal to the formula and solve for K. Or you can do both, like I did, as kind of like a hybrid approach. You've heard me say this in the past. If you followed the series at all, I want to give you some options for thinking through questions in case one or the other makes more sense to you. And that kind of problem-solving flexibility really pays on the quant section in my experience. And also, it's good to remember that our minds, all of our minds can work a little bit differently at times. And the way I like to conceptualize something might be a little bit different than the way you like to conceptualize something. But both of our approaches may be totally valid and equally efficient and equally effective. And I think it's worth acknowledging that. In fact, your method might be a lot better for you than my method is for me. So if you got something that's working for you, keep doing it. Interestingly, most popular wrong answer here, option A. Not a huge surprise, though, considering I think a lot of people would maybe forget about 2 to the 0. So another good potential like note to self from this question is that it's worth memorizing all your powers of 2 from 2 to the 0 power up to 2 to the 10th power. I think beyond that's probably not going to help that much. But 2 to the 0, 2 to the 1, 2 to the 2, blah, 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 all the way up till 2 to the 10th. Those numbers are tested pretty heavily in GMAT Quant, and I think it's really nice to be able to look at a number like 32 and instantly be able to recognize like, oh, that's 2 to the 5th. It's not essential, just to be clear. You can always figure out powers of 2 by doing some manual multiplication, but I think you will find it quite helpful in general to have those memorized, so I'd recommend it. To sum up some valuable takeaways on that particular problem, recognizing what powers of 2 means, really, really valuable. Thinking about taking numbers to the power of 0, a little unusual in school math classes, really valuable on GMAT Quant. And finally, potentially memorizing all the powers of 2 up to 2 to the 10th. That would be kind of weird if you did that as a working adult in the business world, but studying for the GMAT, really, really helpful. I think that sums up that problem pretty well. Let's try one more together. This is problem number 58. If x squared equals 2 times y to the third power, and 2 times y is equal to 4, what is the value of x squared plus y? Let me repeat that. If x squared equals 2 times y to the third power, and 2y is equal to 4, what is the value of x squared plus y? Option A is negative 14. Option B is negative 2. Option C is 3. Option D is 6. And option E is 18. Again, recommend pausing, visualize how you would construct your math on test A if you were doing this problem by hand. In contrast to the previous 2 questions, this one isn't very reasoning heavy at all, I don't think. It's more just about doing math. And what you might find interesting is that way more people than average get these pure math questions right than those reasoning type questions. And that's partly why you've heard me talk so much about process rather than just content in this series. The math basic stuff is more the content stuff. This is where we're getting more into how does that stuff actually show up on the exam and how can you connect the dots? So pure math questions like this one that don't involve a lot of reasoning tend to be a bit more familiar from school math classes for most of us. And that's also why I've been doing my best to expose you to a variety of problem types so you can be ready for what you're really going to see on test day. You'll see both types of questions for sure, but content matters and reasoning matters. And this question's a good example of the content side because basically we're going to solve for 2 variables. That's going to be pretty familiar for many of you. But just to be sure everything is buttoned up, let's walk through a correct solution path, and then we'll talk about how to avoid pitfalls. So you might notice that the equation with just y is the most simple equation, and it allows you to fairly quickly get the value of y. So let's begin there. 2 times y is equal to 4. Let's just use the golden rule of algebra and divide both sides of the equation by 2. That gets us y is equal to 2. That's great news because now we can just plug that in for y in the first equation, which is x squared equals 2y to the third. We know that y is 2. We got to obey PEMDAS, so exponents first. So first thing we're going to do is we're going to take 2 to the third power. That's 8. Then we'll do the multiplication part. That's 2 times 8. So the right-hand side of the equation is going to be 16. We've got a math basics episode on PEMDAS for you as well if you need that. So x squared is equal to 16. That's what our equation looks like now. Quick point here. In this question, we're just asked for the value of x squared plus y. So technically, we don't need to solve for x here. We can just use x squared as 16 and use that to get to the answer. But I do want to use this opportunity to drive home my earlier point about square rooting variables versus square rooting numbers. So I'm just going to kind of take a little side quest here. If we did want to solve for x, we would be square rooting a variable. So that would mean x could be positive 4 or negative 4. That's a good example of that. Again, we don't need to worry about that in this problem, but it is a often big deal on future problems, so just be on the lookout for that kind of thing. Now, just in case that's still confusing, we are also square rooting 16 on the right side, which is just a number. So if it makes more sense to you to think about when I'm square rooting a variable and a number, I should think of a positive and negative solution. That's totally cool. But when I'm square rooting only a number and not a variable at the same time, that'll always be positive. Some people find that a little bit easier to conceptualize and memorize rather than square rooting a variable plus minus, square rooting a number, always positive. It's totally up to you. It's the same concept, but I could see a lot of people finding it easier to think about it this way, just in case that helps. Now, we know x squared is 16. We know that y is 2. Question is asking us what's x squared plus y. So that's just going to be 16 plus 2. That yields 18, which is option E as in echo, and that is the correct answer. Again, pretty straightforward math-heavy problem type. If you're good with solving math, this one probably went pretty smoothly. If you're just getting started and it's been a while since you've done algebra or you've never felt good with algebra, which is totally, totally fine. Plenty of people enter into GMAT world in that situation. Again, we've got a whole series to help you reskill on that. Let's talk about some pitfalls here. Option D is, which is 6, is the most common wrong answer. So think about this for a second. Any idea why people might be picking 6 instead of 16? My best guess is that instead of solving for x squared plus y, they're just solving for x plus y, which if we solved for x would just be positive 4 plus positive 2 because we solved for y earlier and that was 2. So if I just do 4 plus 2, I get 6. Please do not do that, everyone. That is a super avoidable mistake, but it's also super, super common. And I do want to be clear. Part of the reason I'm being so heavy-handed with this recommendation is because I wasted months of study time not correcting those small things. And I'm never getting that time back, everybody. So hopefully I can save you some time as a result and make it mean something. So, more to say on that in a sec. I think this one's pretty easily solved. That problem's pretty easily solved by the always writes what's given and asked habit that I've recommended just like to an absurd degree, hopefully at this point. But if you have a better idea for how you can prevent those kinds of mistakes for yourself, then by all means, feel free to stick with your own approach. I am never going to argue with your results. Having said that, it's pretty crazy to me how much it helps to just write what's given and asked 100% of the time. Like I think going into this test, it wouldn't seem like that's going to be a big deal. And it's definitely not a silver bullet, meaning it's not going to guarantee you're never going to miss questions you know how to do, but it usually really reduces people's error rate without much of a time and energy cost. So I'd recommend at least testing it out and seeing if it helps. If you hate it and it sucks and it makes your score worse, then it's pretty easy to stop doing it. That's probably a good place to pause for now. We'll be back soon with more problems to work through together and more tips that should greatly accelerate your progress. Again, if you have thoughts or questions or feedback at any point, please find us at the GMAT Strategy on current social channels or email us at contact@thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. Totally free, huge time saver for the vast, vast, vast majority of people who watch it. Should be a really high return on your time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.